Please give it up for Daniel Hulme.
Hey, I have a lot to cover, so I'm going to talk very quickly. I'm sorry. Don't think, just close your eyes, go with the flow, or go to sleep. It's up to you, I don't mind. We are going to talk about AI. Anybody heard about AI? It's a joke. So we're actually going to give you a different way of thinking about AI that we hear knocking around LinkedIn. I'll give you a framework to figure out how to maybe invest, apply AI. We'll talk about the macro impact that these technologies are going to have on society. So we're going to get quite philosophical if you want. I've been involved in AI for about 25 years. My undergraduate PhD postdoctoral in AI from UCL, where I'm currently entrepreneur in residence. I spun out a company about 18 years ago from UCL that's been building AI solutions for some of the biggest companies in the world, Tesco, PwC. I sold that to WPP 3 years ago, where I'm now the Chief AI Officer, so coordinate AI across about 120,000 people. And I've just started a company to try to solve machine consciousness. So if we want to go deep, we can. That's me, it's boring, let's talk about AI. So I guess for the past 10 years, we've been getting very excited about data. Companies have been building data lakes. They put Tableau or some sort of analytics layer on top. They've been hiring machine learning experts, data scientists, and they hope that by extracting insights from data and giving those insights to humans, that it's led to better decisions. If I'm honest with you, giving human beings better insights doesn't lead to better decisions. But what tends to happen is we get very excited about emerging technologies. 10 years ago, it was machine learning. Now it's generative AI. We then apply those technologies to solving the wrong problems. We blame the technology. We call it a bubble. But the reality is that humans are not very good at understanding what are the right technologies to solve the right problems. Companies don't have insight problems. They have decision problems. And decision making is a completely different field in computer science. If you're old enough, it used to be called operations research. It's discrete mathematics. It's optimization. I will always start with the problem and work backwards. It turns out that humans are rubbish at making decisions. I know you've all probably read the book Thinking Fast and Slow by Daniel Kahneman. Daniel argues that we have a fast brain and a slow brain. And there are parallels in terms of how these brains work with how AIs work, which I'll talk about later on. I want to test your brains now. I know it's late, but I'm going to ask you some maths questions, okay? And your job is to answer these maths questions as fast as possible. If you don't answer them faster than your competition, they're going to take your market. So speed is important. First question, nice and easy. What's 2 times 2? Okay, good. What's 14 times 2? Okay, so the point here, this one's your fast brain. You didn't need to think about this one. You have to go through a process and algorithm to come up with the answer. I'll ask you another few more maths questions, slightly different context. The nice and easy. The combined price of a bat and a ball is £1 and 10 pence. The bat is £1 more than the ball. How much is the ball? If you said 5 pence, you knew the answer already. You're cheating. If you said 10 pence, then you're using your fast brain. So the bat is £1 and 5 pence. The ball is 5 pence. The combined price is £1 and 10 pence. So we use our intuition all the time, making confidently wrong decisions. It's really important to understand what is it that AIs are good at and what is it that humans are good at. Let me ask you another maths questions again. Imagine you've got a delivery van, and your delivery van has to deliver packages around these 24 points around London. Humans are quite good at solving these spatial problems. We can draw a nice path around those points. How long will it take a computer to get the shortest path? The one that's going to save the most amount of time, energy, petrol?
Not possible.
Huh? Can't be done. Seconds, between seconds and 20 billion years. So if you put 24 times 23 times 24 factorial in your calculator, you get this number of roots. That's how many solutions there are around 24 points. If you had a computer that could check 1 million roots a second, it would take longer than the age of the universe to go through all of them and say, this one that I looked at 10 billion years ago, this one's the shortest one. If I had another point of the map, it becomes 25 times 20 billion years, so 5,000 billion years. If I had another point of the map, it becomes 26 times 5,000 billion years. These are exponential problems. They get ugly very quickly. There are lots of these problems in industry. They're being solved by human beings badly, or they're being solved by algorithms probably badly. One of my clients is Tesco. They're delivering to 200,000 points on a map a day. The point here is that if you use the wrong algorithm, it will literally take longer than the age of the universe. If you choose the right algorithm, it will take milliseconds. That is the opportunity cost in choosing the wrong algorithms. So if I build a system that I give data to and it makes a decision, and tomorrow I give the same data, it makes the same decision, what I have is automation. And automation is amazing because we can get computers to do things better than human beings. But does anybody know the definition of stupidity? Yeah, so doing the same thing over again and expecting a different answer. I would argue controversially that by definition that automation is stupid. It's not AI. I know that everybody that currently touches these words calls themselves an AI company. It's fine. We get more clients. We get more funding. Thank you. There are unfortunately many definitions of AI. The most popular definition, I think, is the weakest definition by far, which is getting computers to do things that humans can do. 3 years ago, we managed to get ChatGPT to recognize objects and images, to correspond in natural language. When we get machines to behave like humans, and because humans are the most intelligent thing we know in the universe, we assume that that's intelligent. intelligence. Now, there's lots of information and books out there to help you understand that humans are not that intelligent. That's a different conversation. There's a much better definition of AI that comes from the definition of intelligence. Instead of using human beings as the pinnacle of intelligence, there's this very nice definition from the 80s, which is goal-directed adaptive behavior. And this word adaptive has cropped up a lot today. You have to have a goal, routing your vehicles to maximize deliveries, allocating your workforce to maximize happiness, spending your marketing money to maximize return. Behavior is how quickly you can move towards that goal. And again, we've just discovered if you choose the wrong method, the wrong algorithm, it will not be good for your business. If you choose the right algorithm, it will disrupt, it will be differentiating. But the key word in this definition is adaptive. What you want to do is build systems that make decisions, learn about whether those decisions are good or bad, adapt themselves so next time they make better decisions. Adaptation is synonymous with intelligence. And if I'm honest with you all, you tend not to see adaptive systems in production. Almost everything in production right now is automation. So if I held what we do in industry to this definition, one might argue that nobody's doing AI, which is a ridiculous comment because I've built an entire career around AI. But the point here is that using definitions, using technologies to think about AI is not helpful. So I'm going to give you a different way of thinking about it. Before I do a little bit of a history lesson, this is AI in the 60s and 70s. This is Socrates. Socrates is famous for inspiring the Socratic method. If I say to you that Socrates is a man, and all men are mortal, I can infer that Socrates is mortal. AI in the 60s and 70s was writing down lots of things that we know about the world to try to infer new knowledge, and it didn't really work, it didn't really scale. This is having a renaissance, it's called agentic computing. In the 80s and 90s, a new type of AI came along that's modeled how our brains work. This is the brain of a bumblebee. My PhD 20 years ago was trying to model the brain of a bumblebee in a machine. Bumblebees have 1 million brain cells. Their brains can fit on the end of a needle. Bumblebees do amazing things. They navigate 3D worlds, they recognize objects, they talk to each other, they solve problems. They don't handle Windows very well, but ultimately they're very smart creatures. And the question was, can you model 1 million brain cells in a machine? 20 years ago we couldn't. We can now model billions of brain cells, and we call these large language models. Now, I would argue that large language models are really good at knowing things about the world. They're very good at telling you what they know about the world through imagery and text. They're not good at making predictions right now. They're definitely not good at making complex decisions. This is not a panacea to solve all problems across your organization. That said, they are getting smarter. 7 years ago, large language models were a bit like toddlers. They regurgitated some words, some made sense, most of it didn't. 3 years ago, we launched ChatGPT. Arguably, 50% of what ChatGPT comes out with is nonsense. Essentially, it's like an intoxicated graduate. We're moving from an intoxicated graduate to now like a master's level where it can do rudimentary reasoning. Over the next 6 months, 9 months, we'll have a PhD level, so something that can be given a complex task, break that problem down, solve that problem. 18 months later, we'll have a postdoc, something that can do science, push the boundaries of human knowledge, and by the end of this decade, we'll have a professor in our pocket. And by the way, even a professor can't solve that routing problem. Okay, it's really important to understand what a professor can do is build an algorithm to solve the routing problem or use an algorithm to solve the routing problem. So it's really important to understand this is not a panacea for all problems. It's really important to understand what are the right technologies to solve your problem. So instead of looking at AI through definitions and technologies, I look at it through 6 applications. So I'm going to make a bold statement. All of the frictions that we experience across industries, across organizations, can be mapped to one or more of these 6 applications. Okay, so these are the things that can solve those frictions. I know I've poo-pooed it, but the fact is, if you apply task automation in the right way, you can drive a massive amount of value, right? If then else statements, macros, robotic process automation, these simple algorithms, if applied to replace repetitive, mundane, structured tasks, drives massive amount of value. You don't need to gravitate to shiny technologies like machine learning, generative AI. The second category is content generation. Now, we all now have the ability to generate any content, any generic content, imagery, text, soon video, soon sound. This is cute, but it's not going to differentiate your business. I'm now, in charge of AI across WPP. WPP create 1/3 of the world's ads, and our job is to create production grade, brand-specific, differentiated content, and that last mile is extremely hard. I'm going to geek out a second. I don't know how I forgot that. Okay. So there are 4 ways of making a brain smart, a large language model smart. The first way is essentially by asking it better questions, prompting. We can all get better answers by asking it better questions, but it's still only going to be bounded by the knowledge that it has. The second way of making a brain smart is by giving that brain your brand guidelines, in this case, your tone of voice, your written copy, some images, just like a graduate, and you ask that graduate to create an ad, and it'll probably create an ad that's 60% good. By the way, that can be built in minutes, doesn't take long. The third way of making a brain smart is taking that graduate and turning into an expert. Tuning, training. We know how long it takes humans to become experts. It takes years of trial and error, blood, sweat, tears, iterations. There's only a few models out there that you can actually train and tune. And the fourth way of making a brain smart is what we do when we build these, what we call brand brains, is we create an agent that's an expert at your brand guidelines, your written copy, your imagery, your company values, your tone of voice. And just like in the real world, you get all of these different agents collaborating and communicating to get to like a 95% good answer. That's the power of agentic computing. Agentic computing is not just about agency. It's about having different agents to collaborate and reason to get better decisions, multi-agent reasoning. The third category is human representation. So what we can do actually now is build AIs that don't just create content, but recreate how people perceive content. This is a really powerful idea. We call this audience brains in WPP. So if I show you an ad, historically I didn't know what goes in your mind and body unless I ask you, and people are not very good at reporting on what goes in their mind and body. For the first time ever, we can build brains that recreate how people perceive things, who people you're selling to, your customers, your employees, and we can then use those signals to create better content, but also predict activation. This is a really important, powerful concept, and I think there's an opportunity for organizations to differentiate themselves in this space. The fourth category is what people called AI before generative AI, so 4 years ago. It's machine learning, it's data science. You already know my opinion. Giving human beings better insights doesn't lead to better decisions, but the power of machine learning is not making predictions. The power of machine learning is explaining those predictions. So again, if I show you an ad with a black cat, I can predict the clicks and the likes and the sales. But what machine learning can do, if you build it properly, it can say, Daniel, if you change that from a black cat to a ginger cat, you're going to get more clicks, likes, and sales because that person likes Garfield. It's a terrible example, but the point is, you can use machine learning to extract insights from data in ways that human beings can't, to then use those insights to make better decisions. Decision making we've already talked about. A lot of organizations don't realize how complicated decision making is. Let me just give you another example. Imagine you've got 5 staff members. Maybe you can recognize yourself here. And what we want to do is we want to allocate 5 staff members to 5 jobs. How many possible solutions are there? How many ways can I allocate 5 people to 5 jobs? We've done the maths already, 5 factorial. So it's 120 possible solutions. Let's make the problem more complicated. How many ways can I allocate 15 people to 15 jobs? Don't say 15 factorial, that's cheating. What does your fast brain say? How many ways can I allocate 15 people to 15 jobs? It's over 1 trillion possible solutions. To expect a human to solve this problem, we are wasting our time. So one rule to take away today, anything more than 7, don't use a human for. In industry, don't have problems of this size, you've got problems of this size. So you have 500 staff members. Can you tell me how many solutions there are? No, you can't, it's a big number. It's the number that's got over 1,000 digits. And just to put this number into context, this is how many atoms there are in the universe. Once you reach about 60 things you have to consider, there are more solutions than there are atoms in the universe, which is why it's very important to choose the right algorithms to get to a better solution. The final category is human augmentation. So a few years ago, I'd be talking about how we can use exoskeletons and cybernetics to make ourselves faster, better, stronger. One of the things that we've been doing for many years in my company, actually, we've been building essentially digital twins of employees. You can take the large language model and we can train that large language model on people's feedback, their email, their calendar, their correspondence. I can ask that digital you, if I put you on this project, will you work well? If I put you on this team, will you thrive? And that digital twin is being embraced by employees because they feel like it represents them better than 5 numbers in a HR database, and it really does. And actually, what's exciting is you're all now starting to create digital twins of your personal selves. You might have an assistant on your phone. That's not an assistant. It's really becoming a digital you. It's learning about your hopes, your dreams, your desires, your preferences. I'm in the world of marketing now, and we need to figure out not only how do we market to human beings, we need to figure out how to market to AIs. There's a new channel which is quite exciting. So I love these categories because they help you navigate this nonsense around AI security, safety, governance, and ethics. There's a huge amount of scaremongering, misinformation associated with these words. I think there are 3 things you need to ask yourself when implementing AI. The first one is the intent appropriate? Is this the right thing to do? Now, I know there's people that have rebranded themselves as AI ethicists. I would controversially argue there's no such thing as AI ethics. The difference between humans and AIs is that humans have intent, AIs don't have intent. And it's the intent that needs to get scrutinized from an ethics perspective. The 2 other questions are my algorithms explainable? Really, the only difference between AI and software is that AI tends to be opaque in terms of how it makes its decisions. If you make it explainable, which is very hard, then you can then, most of these words go away, they become transparent, audible, all that kind of stuff. And the final question you need to ask yourself is not what happens if my AI goes wrong. You know, as engineers, we identify failure points of the systems that we build and we mitigate those failure points. You now have to ask yourself, what happens if my AI goes very right? What happens if it overachieves its goal? What harm can it cause? And I can give you lots of examples where AIs would have overachieved the goal and it would have caused harm in the supply chain. There's a don't have time. Yeah, okay. There's a human bias called homophily, which means we tend to like and trust people that look and sound like us. So if I let AI loose to optimize marketing campaigns, you end up with a world of you selling to you. Now that might be very good for business, but it might be enforcing bias and bigotry and social bubbles. And these are the things that we need to think about. Okay, so we talked a little bit about innovation. The more you can innovate, the more adaptable you are, the more innovative you are, the more intelligent you are. I love this definition by Steve Jobs. He said that innovation is creativity that ships. And for me, the most important word in this definition is the word that. That is generating ideas and getting them to the point where somebody's willing to pay for them. And when I'm looking at startups I'm investing in, I'm looking at how quickly they can get to market, how quickly they can adapt to a rapidly changing world. We talk about moats, we talk about defensibility, but really your key opportunities, your key feature for success is your ability to adapt. I think there are three things. Oh, thank you. Somebody gave me some extra time. I think there are three things that differentiate an organization in the world of AI. We've talked a little bit about this data. If you've got data that contains insights that are more useful than your competitors, then you have an advantage. Because it's data that makes AI smart. The second is AI talent. Now, I know we all think that we can hire deep mind level talent. We can't. We have to be really honest with ourselves that if you want to build differentiated AI solutions, you have to hire differentiated AI talent, or you have to engage with that somehow. And WPP is very lucky they bought my company, and I can sort of call ourselves a WPP DeepMind because DeepMind trying to steal my employees. So I'm very honored that they try and steal my employees. I can't steal them back because I can't afford 5 times their salaries. But if you really want to be honest with yourself, can you attract and retain deep AI talent? Because this is one of the biggest reasons why companies fail. And finally, it's you. It's leadership. It's people that need to understand how to apply these technologies in the right way. We don't have time to go wrong. We don't have time for misinvestment. We don't have time for proof of concepts. We need to make sure that we're placing the right bets now. And that means engaging with people that really do know what they're talking about, not people that have rebranded themselves as AI experts over the past 3 years. The next thing. So we'll talk about this. So we're moving now from AIs to agents, and my guess is over the next 2 years, companies are going to deploy agents, essentially an army of intoxicated graduates across their workforce, and it's going to be a shit show, forgive the technical term. And what's going to happen is that people are going to realize that they've been deploying agents that are not fit for purpose, that they think they can do their job and it's not, and it's actually going to provide an opportunity. But what's going to happen is that those agents are also going to move to the physical world. So the robots I'm a big fan of, nice. And I think that what's going to happen is that, by the way, there's a lot of scrutiny around large language models. They're energy, they require lots of data to learn, et cetera, et cetera. The reality is that your brain operates on the power of a light bulb. You learn very, very quickly. You only need one piece of data to learn what things are. And I've been tracking this since my PhD 20 years ago, but there's some emerging innovations coming out of academia, actually also in the UK, called neuromorphics. They're not GPUs, they are essentially spikes. Your brain spikes. There's only some parts of your brain that are active at one time. This is a really interesting area to invest in. I think it will also spawn the robotic revolution, but I also think it's going to create machines that become conscious, which I think therefore neuroscience is going to become a very important new emerging field, which I'll talk about in a second. We've talked a little bit about AI risks. So one is, how do we deploy these technologies in production? How do we mitigate bad actors from creating pathogens and bad actors? And this is the role of the government to try and solve. But I think there are some big macro risks that we're facing as a species that I'm hoping that you're going to help solve by investing in the right companies. So I think you've all heard the word singularity. Singularity, it comes from physics. It's a point in time that you can't see beyond. And it was adopted by the AI community to refer to the technological singularity, which is the point in time where we build a brain 1,000,000 times smarter than us. I think there are at least 6 singularities. So I've tried to use this word, this pestle, which I'm sure you're all familiar with, this macro framework, to try and capture them. So the first singularity is the political singularity, a post-truth world, a world where people no longer know what is true. AI, misinformation, bots, deepfakes have challenged our political foundations. They continue to challenge our political foundations, but they're also challenging the fabric of our reality. With a few seconds of your voice and a few images, and for $5 I can clone you. And I know people who are being cloned, and their clone are being used to commit fraud. In fact, Mark Reed, the picture of the guy earlier, the CEO of WPP, he was cloned last year, and somebody tried to use his clone to commit fraud in WPP. I think we can solve this problem, by the way. The environmental singularity we've talked a little bit about. So we know that AI is increasing consumption. We know that consumption is putting pressure on our planetary boundaries. We know there are people that overconsume. if you want a gold-plated Lamborghini, then you probably need a therapist. But if we apply algorithms in the right way, our supply chains are horrendously energy inefficient, they're horrendously unoptimized. If we apply algorithms in the right way, I think we can at least half the amount of energy that we're currently using to run this planet. And the reason why I say that is because every project that I've done over the past 18 years, we typically reduce the amount of carbon by 25% and unlock more capacity. If you can then start to co-optimize across supply chains, you can reduce the carbon even more. We can get control of our ecosystem if we're smart about using algorithms. This is not my expertise, but there are scientists that believe there are people alive today that don't have to die. AI is advancing medicine. It's able to monitor ourselves and soon maybe clean ourselves out. And a bit like a car, if you stay on top of damage, that car will never ever break down. I don't know what the world will look like when we realize there are people amongst us that won't have to die. What I did do recently, though, is I signed up to a website called tomorrow.bio. I don't know if you've heard of that. So if I die now, which is possible, somebody will come and they'll take me to Sweden. They'll freeze me and they'll take me to Sweden for the price of $5 a week. So the point here is that for $5 a week, you could all maybe cheat death. They don't know how to unfreeze you yet, but for $5 a week, you could potentially cheat death. The technological singularity is when we become the second most intelligent species on the planet. Now, my community felt this wasn't going to happen for another 40 years. Because of the AI arms race that's been kicked off, we think it is now going to happen in the next 5 or 10 years. My advice to people is that when superintelligence comes, look busy, be nice to each other, and hopefully we'll bugger off to a different dimension. I am a little bit worried about this singularity. So I've just started a company a year ago to try to build a safe, aligned, conscious AI. The hypothesis is an aligned, conscious AI will have empathy, sympathy for things that are conscious in the way that we do and might not remove us from the equation. By the way, this have a massive commercial opportunity as well, platformizing neuromorphics, verified agents. So if you want to invest, please come have a conversation with me. The legal singularity is when surveillance becomes ubiquitous. So I am now explicitly in the business in WPP to understand perception and influence people. That's the explicit goal of marketing. We all are in the business of persuasion, but AI is becoming really, really good at understanding people's unconscious biases and exploiting those unconscious biases. And we need to make sure that we're using that AI safely and responsibly, and we're not allowing bad actors from using these technologies to accumulate more wealth and more power. I'm going to close by saying my favorite singularity is my favorite singularity is coined by a very good friend of mine called Callum Chase. Highly recommend his books. This is the point in time where we automate the majority of human labor. I know there's lots of opinions about this. I'm going to give you my opinion. For the past 18 years, I've been using AI to free people from mundane, repetitive tasks. Those people have not lost their jobs. They've gone on to do more important, more impactful things. I think that for the next 5 years, we're going to see a Cambrian explosion of new innovations. You're going to be, funding startups. They're going to be, creating new growth. AI is like an energy source that will allow humanity to grow. I think beyond 5 years, nobody knows what they're talking about. And to give you the two extremes of the argument, the first extreme of the argument, if we can free up whole jobs, which we probably will soon, then we will. And if that happens very quickly, then our economies won't be able to rebalance and it will lead to social unrest. And I actually think we need to lean into that problem. 4-day working week, UBI, whatever. The other extreme of the argument is that we should be accelerating as fast as possible towards a singularity. We should be automating the friction, which usually means human labor, from the creation and dissemination of goods, food, healthcare, energy, transport, education. By removing the friction of these things, you can bring the cost of them down to almost zero. So imagine being born into a world where you don't have access to paid work, but everything you need to survive and thrive as a human is free, is abundant. People say to me, Daniel, what would I do if I didn't have a job? A job defines who I am as a human being. I know lots of people who don't have jobs. Probably most of you don't have jobs, and real jobs anyway. And most of the people I know that don't have jobs, they're not sitting at home bored and depressed. They're using their time and their energy and their assets to try and make the world a bit better. So I'll ask you all a question. What would you do if you didn't have to do paid work and everything was free? What would you do? I know some of you are thinking golf. I know it. What would you do if everything was free? Golf, travel, indulge in your hobbies, spend time, yeah? Exactly. So if you push people hard enough, they say the same thing. I want to do something to make the world a little bit better. I think we'll all have an innate desire to want to make the world better. And I think that if we apply AI in the right way, we can create that world. So I'm going to close by saying it's not good enough for organizations just to have a strong, profitable business, particularly startups. You have to have a purpose. If you don't have a purpose, you're not going to attract AI talent, and you're probably not going to attract customers. I sold my company to WPP because I believe in their purpose. It's to use the power of creativity to make a better future. And I think a better future is a world where everybody is economically free to live their true humanity and contribute to the world to make it better. So on that note, I'm going to stop. Thank you.